Gracias. Thank you so much for having me. So I think that I have a little bit of an advantage being a keynote speaker on the last day because I've had a chance to get to know a lot of the organizers and the attendees and just really experience the city and the community that you all have here. And I've just been like absolutely blown away by how like inspiring and all of the energy and commitment to furthering your community and furthering the lives of each other. And that's just been incredibly inspiring. So kudos to you all. So one of my goals coming to Colombia for the first time was to eat my weight in arepas and empanadas. And so I also have to thank you all for helping me achieve that goal. All right, so who knows what this is? Good, shout it out. Yeah! So this is the assignment operator, also very warmly known as the walrus operator. So if you haven't seen this before, if you sort of like turn your head to the side, the two dots kind of look like eyes and the two lines sort of look like tusks. So I'll help you out here so you can see this a little bit better. And so this is actually an illustration of the walrus operator that I had put together for celebrating the release of Python 3.8. And I really love this. I also really love that I get to see it like on this huge giant screen because I can see all of the details. So he actually has like little walrus operators in his scarf and a little like Python skull and bones tattoo on his arm. So this is just a whole lot of fun to put together. So what does the assignment operator do? Essentially what it lets you do is both assign and return a value in places where you couldn't before. And you get to do both assignment and returning at the same time. So here's a super simple example. We basically have an A, the assignment operator, and a 10. And so the way that you read this is A becomes 10. So in this context, it's not really going to behave much different than like a normal assignment would. This is just sort of like a very bare bones introduction to how and where you can use the assignment operator. So here's an example of like pre-assignment operator code. So you can see here that we're having to actually assign to our env path variable, do a check against that variable, and then write some code that potentially uses that variable. And so rewriting this, we can kind of simplify it a little bit, and at the same time as we're checking if the environment path exists, we're also assigning it into that variable at the same time so that it can be used within the body of that if statement. So Python 3.8 was released in October of 2019, and so this actually caused a huge rift in the Python core development community. But how is it that adding two tiny little symbols to a new language could be so divisive? So a little bit about me. My name is Emily Morehouse. I am most well known for implementing this very controversial piece of Python syntax. I'm also the Director of Engineering at a company called Cuttlesoft. We are a digital product development company. So we make anything from web and mobile applications to CI/CD pipelines to cloud architectures and embedded systems and sort of anywhere in between. And so it might also surprise you that even as a Python core developer, I write a ton of JavaScript and other languages as well. So one of my favorite front-end hobbies has been designing a screenshot testing tool that compares visual diffs of images. So what you see here is on the left, it's like the normal PyCon Colombia website. And on the right, I made some like very, very small tweaks to the appearance of the website. And so if you have a very keen eye, even on these smaller screens, you might be able to actually pick out what the difference is. But what I did is I actually used a visual image diffing tool to actually like overlay the two images and highlight the differences between the two so that you could look at this and go, oh yes, I meant to make all of my buttons green, or oops, no, I actually meant to only make one of those buttons green and I accidentally made all of them green. So it kind of like highlights the things that have changed so you can see what you wanted to change and what you didn't. So there are a few products out there that do this, but if you're interested in visual testing or how you can do this yourself, definitely come find me after. This is not what my talk is about today. But one of the things that I love the most about my job is how many different technologies I get to work with on a daily basis. I'm actually like often switching between building hybrid mobile applications and native mobile applications, writing CloudFormation templates for AWS, web APIs, or embedded systems that handle complex asynchronous communications within the system, but then synchronously return back out data to an API. So this has taught me that, for one, if you're bored in tech, then you're not working on the right things, and it's time to learn something new. And two, there's really great value in learning not just the hard skills for programming, but really how to think like an engineer. I wouldn't be able to execute in so many different environments and different areas of tech without having learned to approach problem solving and learning new things quickly. So how is it that we learn new things? Well, I took a look pretty far back into our world's history, and in the 700s AD, there was a place called the House of Wisdom, also known as the Grand Library of Baghdad. This was an intellectual powerhouse of knowledge and culture. Scholars of all kinds would gather here to document and translate their shared knowledge, from alchemists and engineers to historians and architects. It sat as the centerpiece of Muslim culture in Baghdad's heyday over 1,300 years ago. There was a desire that grew out of this concentration of scholars. It was to share knowledge as widely as possible. It created a translation movement that lasted over 2 centuries. Texts from Pythagoras, Plato, Aristotle, and Euclid, among many, many others, were translated into different languages in order to be more widely understood. And so the availability of this new knowledge propelled scholars towards studies and new discoveries in medicine, agriculture, finance, and engineering. Copies of these manuscripts, though, took a long time to actually create because they had to be copied word by word and letter by letter. On February 13th, 1258, over 500 years later, Hulagu Khan led the Mongols into the city, starting a full week of pillage and destruction. The Mongols laid waste to the city and left nearly nothing in their wake. Half a millennia of acquired knowledge was wiped out in a matter of days, and 100,000 people were killed. It is said that the Tigris River ran dark with the combination of ink and blood as a result of the carnage. Ink of words that no one may ever hear again. But I'm not here to talk to you about the Islamic Golden Age or lost manuscripts. We don't use manuscripts today. We have digital documents with cloud backups that we can share and persist across the internet for the future of our Earth and our universe as we know it. We no longer have to be at risk of losing information that has been written down. Just don't trust storing it on an SSD for more than a year. And so I think we have a lot to learn from this ancient society. There was a focus, a community built around disseminating knowledge amongst our peers, much like the conferences we have today. But they were able to experience firsthand that the knowledge that they shared gave others a foundation to start from and build on top of, instead of having to start from scratch. Our lives as developers are driven by documentation and well-commented code, or at least that's the hope. We roll our eyes when documented behavior doesn't match actual behavior, and we mentally slam our fists on our desks when a documentation site goes down for a few minutes, or if the installation of a package isn't easily installable from documentation in the README. But writing great documentation is really difficult. We have biases that prevent us from seeing our projects with new eyes. As experts or creators of a language or a library, how do we know what beginners need to read in our documentation? How do we deal with assumptions about how much somebody might know about the technology, the computer system, or even just interacting with a CLI? As a library or language maintainer, this is one of the many, many issues that we encounter. So in 2015, I first heard the term Python core developer. If you'd asked me then what a Python core developer was, I would have had no idea what it really entailed. I thought that a core developer was someone who helped build and shape the Python language, which is at least partly true, but there's a lot more to it. So like much of my journey, the way that I got into core development was pretty serendipitous. Don't get me wrong, I think that there are a lot of other factors that contribute to a person's success, including sheer hard work and persistence, but exposure to opportunity is definitely a contributing factor. So I attended my first PyCon 2015 in Montreal, Canada, and this was a pretty big milestone for me. I had recently dropped out of getting my master's in computer science to start Cuttlesoft, our small consulting company. And in a way, it was sort of proof to me that we were doing something right, that our small company could send me to a conference of that scale. But at the same time, I felt really conflicted. There were a lot of passions that I was leaving behind. I had been conducting research on compilers and parsers and language design to go start a business that did none of those things. And so it was during this PyCon that Guido van Rossum, our beloved, now emeritus BDFL, made an announcement. Out of 130 core developers at the time, there were no female core developers. It was his very public goal to have at least 2 female core developers by the following year. And so I thought, oh my God, I can totally do that. Like, this is exactly the thing that I felt like I was leaving behind, that I now have this new opportunity to find it in a new way. And so as luck would have it, I did have a chance to meet Guido then. We wound up at the same post-conference event where my boyfriend, now husband, and another conference attendee kind of encouraged me to get up and go talk to Guido. So I kind of reluctantly did, and I told him that I had heard his announcement and I was really interested in getting started. And so right around that time, this new friend that we had made sort of walks by and takes this flash paparazzi style photograph of us in this dark venue, just totally inconspicuous. So I have this really, really amazing talent of turning bright red in a moment's notice. Which I basically proceeded to do while burrowing directly into the ground and backing away slowly. And so Guido was very, very kind and told me hey, here's my email address, email me, and I'll see if I can help you out, sort of thing. But I didn't. I was incredibly humiliated by this interaction, and I was there is absolutely no way that I'm going to email him or speak to him ever again. Is kind of how I was feeling. So PyCon 2016 sort of came and went, and there were still no female core developers. In response, Guido kind of said, hey, I will personally mentor anybody who's interested in contributing to CPython. So at this point, I was kind of kicking myself, and I was like, come on, there's still no female core developers. This is something that's sort of really messed up in this society. We see this a lot in tech, and I was like, I can't keep letting this one small event get in the way of me doing something that I was interested in doing. So I emailed him and made a joke about how he probably remembered this really embarrassing situation. And in a very Guido way, he moved on graciously and invited me to start mentorship meetings with him every few weeks. So now I had never been officially mentored before, so I didn't really know what to expect. I suppose I went in thinking that he was going to give me a bug that was in CPython and be here's this bug, go and fix this bug and bring it back to me with a solution, and I'll make sure that it's good, and that would be that. But he didn't do that at all. He just left it completely open to me to sort of shape what I wanted to learn and do. So new contributors to CPython are pointed to the Python dev guide and the bug tracker, and are just sort of told to fix bugs and fix documentation typos and just sort of learn the process of contributing to open source. But this isn't often a very fruitful process. Bugs that can be easily fixed are often patched in record time, and the ones that are remaining have these really long and windy threads of comments where it's well, maybe this will fix this, but we can't do it because of this, and then they just kind of peter out, and there's no real solution to how to fix the issue. So it's really not a great place for somebody to start and feel any sort of validation, because you can't come in and make any sort of impact very quickly. And I forgot to move my slides. So I tried to take this experience and learn from it. If I had started on a bug and somebody else submitted a PR before I did and before I could fix it, I would try to finish my implementation and then compare it against the core developer's patch that got submitted. And so this allowed me to see things about the CPython environment that I wouldn't have necessarily known otherwise, whether that was like a helper function or a different way of doing things or different impacts that changing a certain piece of code would have somewhere else that I never would have thought about if I had just kind of gone in there and fixed it myself. But at the end of the day, I still didn't really feel like I was contributing anything. Since that didn't seem to get me anywhere fast, I kind of decided to go back to my roots and the things that I was interested in. So what I did is I actually just started reading through the source code and stepping through the parser and the compiler and the interpreter to figure out how all of the CPython internals worked together under the hood. And I just like put a bunch of print statements in there or would attach the debugger and walk through it. And so this is something that you totally can do too. I think that reading and understanding the source code of the libraries and tools that we use is a great way to sort of level up our skills and get familiar with the code base. And even if you don't understand the code at first, it's a tool that you can use to see how others architect and write code, whether good or bad. So Guido kind of warned me that these parts of the code that I was interested in didn't really change much. There weren't really any bugs in Python's compiler or parser that needed to be fixed. Any sort of optimizations to the compiler that could be done had been done. And really what I found myself looking at was code that hadn't been touched in 15 plus years. And I thought, well, this is fine. I'm just gonna like keep doing what I'm doing because I'm enjoying it. And I feel like I'm learning a lot. So I decided to just sort of keep going with it. And so not having any idea what on earth I was looking at sort of turned into this process of like learning and discovering. But it really did come in waves. Sometimes I felt like I was doing something really, really cool. And then other times I felt like I wasn't doing anything at all. And so I would get really introspective and doubtful of any lack of progress that you could put on paper. What I realized was that I hadn't taken the path that I was told to take. And I wondered to myself, did I make the wrong decision? Was I doing something wrong? Was I just not cut out for core development at all? Maybe I should have started off with documentation fixes, and I was just trying to do too much as a new contributor. I struggled, and I think that if I hadn't had the support of a mentor who was there, kind of like keeping regular tabs on me and checking in, I probably would have walked away. Because to me, it really looked like all of these other people who would become core developers had been successful really, really easily. People don't tend to talk about their difficulties or like struggles that they hit along the way. So it was really, really difficult for me to like look at other people and see them be successful. Ooh, that's good. So it was really hard for me to look at other people being successful and kind of like compare myself against that. At least I didn't spill water on my computer. That's the good thing. All right. So on September 12th, 1940, barely a year after the beginning of World War II, an 18-year-old mechanic named Marcel Ravidad was walking with his dog, Robot, in southwestern France when the dog fell down into a hole. Ravidad and his two friends investigated the hole and discovered a 49-foot deep shaft, and in doing so, rediscovered a place called the Lecaux Cave. Now, the walls and ceilings of this cave were covered in hundreds of paintings from long-lost ancestors, consisting mostly of depictions of animals, but also of these like childhood art project-style outlines of hands, many of which were actually missing fingers due to like amputations that had been caused by frostbite. And so our modern minds sort of warp the interpretations that we have of this work, but the fact that it was so important to these people to document these ideas and depictions of their life says a lot about the priorities that these ancient hunter-gatherers had. Their primary goal in life was merely to have enough water and food to survive in a time where resources were very scarce, and yet this is what they wanted everyone to see. So this was a cave that was visited by over 1,200 people daily after it was discovered and opened to the public, but it started deteriorating. Mold, lichens, and crystals started to form in the cave, and the mere presence of human beings being in that environment was just making it all the worse. John Green said in his podcast, The Anthropocene Reviewed, just the act of looking at something can ruin it. A replica of the cave was created so that humans can still view the sort of shell of the original work without destroying it. But it's kind of ironic that in order to protect something, we must keep people so far away that they can't actually experience the real thing at all. So there's so much history and so many stories that aren't told by looking at the code of a project, especially with a code base as old as CPython, that doesn't get communicated or archived. So some of my favorite moments were when I would come across something in these sort of like meandering discoveries that I would find particularly confusing, and I'd ask Guido, like, why is it this way? And he would say, oh, now that's interesting. And I would find out about all these sort of like relatively innocuous pieces of code that turned out to have really, really interesting backstories as to why things came to be that way. And so we have relics, much like these cave paintings, but the context is lost, and our collective knowledge changes over time. I would have never learned these things if I hadn't stumbled across them and asked about them in the time that I still had left to do that. And so having a respect for the history of a project is really, really important. With CPython, it would be great to come in and just like rip a bunch of things out and do it better and in a more modern way, but it would completely disregard all of the reasons why those decisions were made in the first place. So where does our history live then? Has it been adequately tallied and noted, or does it live in these like temperable, fallible human minds? And so my process went on for a long time. It was probably about a year and a half. And I kept worrying that like at some point during these like mentorship meetings that I was having that Guido would say, like, all right, this has been going on long enough, like, I'm bored with this, or I need my time back, or whatever the excuse was to kind of like step back and kind of let me go along my way on my own. But he didn't. He never said any of those things to me and was never anything but supportive. And the fact was that it was all in my head. Like, it was all these things that I was enforcing upon myself and the expectations that I had set for myself that I thought that I wasn't meeting. So PyCon 2017, I was invited to attend the Language Summit. So this is where sort of all the core developers get together, as many people who can attend PyCon, and just sort of talk about all the new ideas and issues that we have in the code base. And so I just sort of like crept in the back and just like sat there and soaked it all in and like didn't really talk to anyone. So if you haven't guessed it yet, I'm actually a huge introvert. So it's really, really hard for me to like just go up and randomly talk to people. But by May of 2017, we had our first 2 female core developers, and Guido's goal was met. So skipping ahead a year, I decided to make a little bit more of an effort to participate. I started reading the Python dev mailing list more closely. I started interacting with other core developers and just sort of introducing myself to them. And around this time, 2 really big things happened. So at PyCon 2018, a controversial debate was settled, and a monumental change was coming to Python. So changes are made to Python through a mechanism called Python Enhancement Proposals, or PEPs. So PEPs can be drafted by any member of the community and can then be reviewed by the core developers to see if they should be incorporated into the language. And so at this time, Guido sort of got the final say for when PEPs were approved. And so PEP 572 for assignment operators proved to be one of the most controversial PEPs in Python's history. It introduced this new syntax, the walrus operator that I talked about earlier. And at this point, it was right around PyCon 2018 that Guido declared that he was going to accept this PEP. But right after that, he decided that he was going to step down from being Python's BDFL. And so this process of getting this PEP approved had taken such a huge toll on him between like all of the debates and mailing lists back and forths and people actually getting really, really, really angry about a relatively small change to the language. But through this sort of series of unfortunate events for Guido and for the rest of the core development community who went through this process, something sort of lucky happened for me. And that was that Guido asked me if I wanted to implement assignment expressions. So like, this was sort of the moment where everything came together. Like, everything that I had worked on and looked at for the past 2 years had fallen right into place. I was sort of poised as the best person who could actually tackle this new problem, because it was all the pieces of code that I'd already been looking at. And so he told me, like, this is going to be pretty difficult, but I'll be here to help you whenever you get stuck. And so these were actually some of my favorite moments. At our office, like Cuttlesoft's office, we had these whiteboard conference tables, and I would just go in there and like cover the entire thing with like design notes and implementation details and like trying to figure out how on earth I was going to like accomplish some of the memory table lookups. And so over the next couple of months, I had implemented just about 90% of what I knew needed to be done for it. At this point, I was very graciously invited to attend the core developer sprint in September, where all the core developers get together and actually work on the language. So we sit together for a week and just work on bug fixes or triaging the build bots or like talking about new solutions to problems and all of that. And it was here where I officially became a core developer. But from the outside looking in, there's really no way to know how much went into my journey without me telling you all of this. There isn't a commit log of my successes or my breakthroughs in understanding or my doubts or the many times when I felt like maybe I wasn't cut out for core development. So my path didn't wind up being the one that I expected, but I imagine that it feels that way for a lot of people. I had to give myself the time and space for things to happen sort of as they needed to and not how I wanted them to. And in the end, it sort of turned out all the better for me. It also takes a lot of time. One of the most important pieces of being a core developer is gaining trust with each other. We have to trust that each other will withhold the CPython name, that we'll be good community members, kind to other people, that we won't sort of merge in PRs haphazardly, and that they'll take care in the code that they're crafting. So it's not really something that you can measure in the number of commits that somebody has. Now that I've had a little bit more time to sort of distill my knowledge on this, I do have a better idea of what a core developer actually does and how you can use this to sort of guide you to be successful to contribute, whether that's to CPython or to another open source project. So it's sort of given that core devs contribute code and must be trustworthy. It's also important that they can guide and participate in thoughtful discussions around their own code and other people's. So currently the CPython repository has over 1,000 open pull requests. And each one of these PRs actually has to be reviewed by a core developer and decided if it's going to get merged in or not. And so we need a team of people who can sort of handle this with a lot of empathy. Dealing with people anonymously on the internet is something that is not always very pleasant. And it's really easy to come across as sort of curt or unkind to people. So this is something that's really, really important as we need to like grow the number of people who do contribute to the language. The other thing that you can do is sort of find modules that don't have experts listed and give them just a little bit of TLC. So if you make an effort to mentor a few core developers or meet other people at a conference, just reaching out directly and talking to people about what it's like for core development is really helpful. One last thing that you can do is just sort of like become a module expert and take one under your wing. There are a lot of different modules in CPython that were, written by somebody at one point, and then that person sort of disappears and doesn't contribute for a while, and they just become orphaned. And so you realize that you have modules in this like Python standard library that aren't being maintained anymore, which can be problematic as our technology and our hardwares and computers are changing over time. And so there are a lot of ways that people can contribute to a project. Contributing code is not the only thing that we need. There are tons of other roles to be filled. Open source is really tricky because often you'll start contributing because you want to write code, only to find out the most important pieces and the most impactful ways are to actually encourage others and support others so that they can contribute. So between 1500 and 1800, during the Age of Exploration, it's estimated that a disease called scurvy killed at least 2 million sailors. Symptoms would include swollen, bleeding gums, loose teeth, bulging eyes, and swelling of the bones in one's arms and legs. A cure was discovered in 1535 when French explorers were treated by Native Americans with a special tea. Many captains thought that a connection could be made between fruits and vegetables and the gruesome disease. A cure was also discovered in 1734 by a Dutch physician, again tied to fresh vegetables. The cure for scurvy has been infamously discovered and lost over and over, knowledge that could have saved time and certainly lives. And we know today that the simple cure for scurvy is none other than vitamin C. And in fact, we've seen a lot of efforts to sort of try to fix problems like these that occur. Every year, 4 million newborns die in the first month of life, 99% of them in developing countries. This is equivalent to the number of babies born in the US annually. So 3 out of newborn deaths can actually be prevented with low-cost tools and teaching mothers the importance of keeping their babies warm. But what did it take to do that? Well, it took the Bill and Melinda Gates Foundation $80 million for this effort. But it's just a small piece of knowledge that was so small and trivial that made huge impacts in people's lives. And so we know that time is money. That's why our bosses don't want us to spend weeks trying to find the most perfect solution when the one that we can sort of hobble together in a matter of days is perfectly sufficient. We forget that by documenting things, we help all future engineers who touch that code to better serve it. Just a few minutes of writing documentation or code comments while something's fresh in your mind can save hours or even days when you try to revisit it. It's why we build languages and frameworks. It's why we have Django or Pandas or Spacey, because we can take these pieces of our foundation and build on top of them so that we can start at 20% or 30% instead of starting at 0. Can you imagine having to rebuild all of your project dependencies from scratch? No libraries, no Python batteries, no standard library. How much longer would it take you? 5 times as long? 10 times as long? 100? And so anything that we don't write down or teach to other people is ultimately lost over time. And so I've had a chance to learn some of these bits and pieces of how Python got to where it is today. And I've learned enough to ensure that we don't hit some of these same pitfalls again. But the future of Python doesn't lie with me. I'm just one core developer. We need to grow and bring on people who can keep Python going for years to come. But what if other people do hit the same roadblocks that I did and don't have a mentor to encourage them or some way to find out the information? And so we've seen a lot of information about how Python has grown over the years. Wes and Inez both showed this well-known hockey stick of growth that Python has had over the last 25 years. And the number of people supporting the language has actually followed a pretty similar growth. You can kind of see it's not necessarily totally hockey stick shaped, but has definitely increased pretty significantly over time, just looking at this graph. But if we zoom in a little bit and just look at 2012 until now, we've only added about 35 core developers. So if we have about 150, 155 core developers currently who have write access to the repositories, only 82 of them have actually been active in the last 2 years. So Python has an estimated 8.2 million users, and we have 82 core developers. So this basically means that for every 100,000 users, we have 1 core developer. So sort of tying everything back together, why was PEP 572 so divisive? So one of the first reasons that I think is that I like to think of us all as little snowflakes. We are all unique with all of these opinions and different perspectives and experiences, and we all want to be heard and kind of have things done our own ways. And so this is one of the reasons why this was so divisive, is that people had such differing opinions on it. And the other thing is that I think that part of it's a bit of a fear of change, or the way that I like to think of it is a fear of unintended consequences. So Python is an absolutely incredible and overall relatively stable language. Stirring the pot and making changes to the language has to be really, really worth the effort. And so as engineers, we're kind of taught to think about all of these different edge cases that could result from every single scenario when we think about how this change to Python would impact our users. Would something be harder to teach or understand? Will something be used and supported over the years? Is there something that could potentially be taken advantage of and exploited? Could there be an unintended change to this one really, really small undocumented API that just one out of those 8.2 million users is actually using? Okay, so how many, I'm actually gonna go back a slide real quick. So how many people here have been hired at a new job? Probably all of us, right? We've all gone through the process of getting a job. And so we go through this sort of ritual when we get hired. We go through this ritual of getting hired where we talk about how much we're going to get paid and what work we're supposed to produce and how much, what our title is going to be. And we give a lot of value to these things. So this is somebody else who's evaluating us after knowing us for a matter of hours or days, who gets to come in and say, this is the monetary value that I put on your work, and this is what I want to call you. And so we have this really weird sort of external validation where if somebody else says, oh, awesome, yes, you are a software engineer, and it's the first time that you've ever been called a software engineer by somebody else, it's a really validating experience. But what happens when you're just starting out and you don't know what to call yourself, or you're starting off contributing to open source and are feeling all these doubts? It's this really complex thing of wanting to seek external validation, but needing to have the confidence in yourself and your own skills to kind of get you there. And so these things validate us and make us feel like what we're doing has meaning to others. But I don't think that we have to be this badass, confident person all the time. You don't have to be the person who comes in and always has the best solution to the problem and the best ideas or the most elegant code. It's really, really human to be the person on the right, the person who has uncertainties and doubts, and it's completely normal and acceptable to experience that. It's okay to have moments where you don't necessarily know what your next step is or how to solve that problem. You might look up to the people who are on these stages today or people who are the key maintainers of a core library that you work with and think that they're a rock star. And we aren't. We are all people just like you who have suffered from imposter syndrome or doubted their abilities or hit hard times along the way. I've gotten a chance to hear from a lot of different people, whether it's somebody who is a first-time contributor or who is contributing for 5 to 10 plus years, that they at certain times have feelings of doubt. I think it's a little bit more expected that when somebody is new that they feel imposter syndrome, but it was really, really eye-opening for me to hear people like Guido say, I don't know, well, let's figure it out. And I think that if you don't have some sort of sense of uncertainty about what you're doing, I don't think that you're ever really doing something that's new and challenging. And so there's so much pressure to do something that's really, really smart and impactful. I think that there was a reason why I really wanted to be a Python core developer. But I think what I've learned along the way is that it's important to set my own goals and my own expectations and not use the measuring stick that I can compare myself to others against, and only use one that I compare myself against what I want. And so I really love this image, and I think that this is something that everyone needs to hear over and over again, even if you've seen it before. And that's that the things that I know are not a subset of the things that everyone else knows. I don't know anything more than anybody else does, I just know very different things. And so my hope in sharing these stories is that we can demystify this process a little bit and break down how none of the people that you see are rock stars. It may look like it's easy from the outside, or that a lot of these things just sort of happened overnight, and I promise you they don't. It takes a lot of hard work and dedication and making or finding the right opportunity. Python is a language that has been greatly led by a single person, but has been shaped by all of us. I think we need to think about how we can intentionally shape our future, but we also can't forget our past, whether that was the languages that inspired Python along the way, or the unique and intimate knowledge of code that still powers us decades later. So I'm very, very grateful to have had the chance to see people who are incredibly successful say they don't know something or that they were uncertain too. So my call to action for all of you is to be more open with each other. Say when you don't know something, especially if you're somebody who's a senior member of your team. And document your code, transcribe your knowledge, and transfer it to other people to help them out along the way. By supporting each other through the highs and lows and making very, very conscious choices about how we interact with each other, I know that we'll go further together. Thank you.